In this question, we're asked to relate several intermolecular forces. And this is really important. And as you may have learned in lecture, learning whether a property like vapor pressure or boiling point or melting point is directly or inversely proportional to intermolecular forces is very important. Otherwise, you can be learning a whole bunch of things instead of just intermolecular forces and how it relates to these other properties. In the first question, we're asked to relate the vapor pressure of a substance with its enthalpy of vaporization. And I'm going to relate these back to intermolecular forces and then back to each other. So it says at minus 9 degrees C, substance C has a vapor pressure of 84 torr, and substance D has a vapor pressure of 114 torr. So I just want to draw a couple flasks. My art skills are not the best, but these are closed flasks, so they're closed on the top. And we have some liquid of C in here, and we have a relatively low vapor pressure, so we have relatively few molecules in the gas phase. For D, we're going to draw the same thing. We have a flask, we have some liquid D in the flask, and we have a relatively high vapor pressure, which I'm going to kind of not do proportionally, but we have lots of molecules in the gas phase. So C has a relatively low vapor pressure, so very few molecules in the gas phase. D has a relatively high vapor pressure, so lots of molecules in the gas phase. If molecules are less easily escaping into the gas phase, it's because C has higher intermolecular forces. Since the intermolecular forces are stronger, less of them at the same temperature fly into the gas phase, therefore there's a lower vapor pressure. So, vapor pressure is inversely proportional with intermolecular forces. Low vapor pressure means higher intermolecular forces. This is atypical. Most of the other properties are directly proportional with intermolecular forces. So now it asks us which has the higher enthalpy of vaporization. Well, enthalpy of vaporization is the amount of energy required for a phase change, specifically the phase change from a liquid to a gas. The higher the intermolecular forces, the more energy it's going to take something and make it from a liquid phase into a gas phase. So therefore, since molecule C has a lower vapor pressure and higher intermolecular forces, it must also have a higher enthalpy of vaporization. Next one, it says at 1 atmosphere of pressure, a substance boils at 101 degrees C, substance A. Substance B boils at 82 degrees C. Remember that boiling point is directly proportional with intermolecular forces. So the higher the boiling point, the stronger the intermolecular forces. That's probably said better backwards. The stronger the intermolecular forces leads to a higher boiling point because you have to add more energy, higher temperature, in order to get those molecules to separate. So in this case, substance A has a higher boiling point, so it has higher intermolecular forces. Now, what does it ask about? It says, which has a higher enthalpy of vaporization? Well, we just talked about enthalpy of vaporization being directly proportional to intermolecular forces because we're going from the liquid phase to the gas phase. We're not changing the temperature, but it's the amount of energy required for the phase change. And in previous videos in this section, we've talked about the phase change diagrams. So, if substance A has higher intermolecular forces, it also has a higher enthalpy of vaporization. So, this is the correct answer. The enthalpy of vaporization of substance E is bigger than that of substance F. So, we just talked about enthalpy of vaporization. If substance E has a higher enthalpy of vaporization, substance E has higher intermolecular forces. Which has a higher boiling point? Well, we already talked about this. The higher the intermolecular forces, the higher the boiling point. I think this is a really great question because it forces you to relate different properties back to intermolecular forces, and then relate those intermolecular forces, relative intermolecular forces, back to other properties. If you think about this in terms of intermolecular forces, it is far easier than trying to memorize the relationship between every property and every other property, such as boiling point and enthalpy of vaporization, or vapor pressure and enthalpy of vaporization, or vapor pressure and boiling point. If you think about it in terms of intermolecular forces, it simplifies it. Again, the vast majority of properties, surface tension, viscosity, enthalpy of vaporization, boiling, and melting points, are directly proportional with intermolecular forces. So the higher the intermolecular forces, the higher those properties. Vapor pressure is the opposite. Vapor pressure, the higher the vapor pressure, the weaker the intermolecular forces, because more molecules can escape into the gas phase, which means the intermolecular forces, in this case for D, are weaker.